hot air balloons. Yay! Mika and Luke are here. Screenomatic hates me, so it's just me. I'm alone in the world. What gases are involved in hot air balloons? It's just the normal atmosphere. Propane produces carbon dioxide and water from its combustion process to produce heat for the balloon, but that doesn't matter to the hot air balloon. It's pretty much just normal air. How does it work? Oh man. Well, the burners of the hot air balloon, they produce heat in the balloon, and PV equals nRT. When the heat goes up, when the temperature goes up, the pressure goes up, and when the pressure goes up in a fixed volume, a fixed volume. Well, okay, there's a fixed volume because it's a finite balloon, but there's also a hole in it. So the pressure does go up, but then it escapes out through the bottom, and then with a fixed volume and a fixed temperature, then the number of molecules change. So you get less molecules because a bunch of them rush out. And now that you have less molecules in the same in the same volume, what changes is your density, which is the weight per volume. And with the principle of buoyancy, now that the balloon has a lower density than the atmosphere around it, it produces lift. And then when the flame goes down, the air cools back down, it gets sucked back in a bit, and then the densities balance out, and it produces less lift, and it floats down. Lamau. References before the application problem, which is your absolute favorite. Elias and Jenny want to go on a hot air balloon ride. The hot air balloon stays constant at a volume of 880,000 liters. When up in the air 1,000 meters, which doesn't matter, the temperature increases to 87.12 degrees Celsius, and the pressure acts against the hot air balloon. The pressure that acts against the hot air balloon is 0.9 atmospheres. What is the density of the air in the hot air balloon? So a few notes. Again, 1,000 meters is arbitrary. We just wanted to show that that's why the pressure goes down, because you're higher in the air. So a hot air balloon works with density. That's why we're having you solve for that, even though it's not a part of PV equals nRT. So we've given you a volume and a temperature and a pressure. So, you know, I don't think it's helping you too much to tell you that you need to solve for, well, I guess it is. I won't tell you that. But there's one other thing. You all know what it is. But that's not what we're asking you. We want the density. So our massive hint here, make sure you can convert moles to grams. The trick with that is that we've given you an air composition, which is 80% nitrogen and 20% oxygen. So, oh, and by the way, density is grams over liters. That's helpful. But we did this earlier in the year, where it's a way to convert the last thing in PV equals nRT into grams. I know it's whack, but oh no. Okay, we're back. It's 4 minutes again. Oh no.